Hi everyone, I want to introduce you to our project called the Stack Neighborhood. So we envision this project as a diverse neighborhood that encompasses more than just an apartment building for students. This project looks into providing high quality living conditions at a rate that is affordable to people of each group and background and foster interactions at every level. With this principle in mind, we wanted a home that we can age in place, meaning its ability to adapt as we grow or move. And to achieve this, our primary concept was the kits of parts that allows us to adapt the internal volume as time moves forward and combine this with the chosen material and design principle. And the Stack Neighborhood was produced. So the kits of part building system of the project is designed as panels, beams and posts and prefab modules, which allows the components to be disassembled and replaced. The walls are made out of CRC panels with fiber cement sheet cladding on the outer layer, while we implement the prefabricated bathroom and kitchen services to fit right in. The panels, beams, and post systems also allow more flexibility and expansion both vertically and horizontally without being restricted to a certain size. Both the material and the system allows for a circular system of use, reuse, and recycle over the lifespan of the building and minimizing waste. So as you can see on the right diagram in our proposal, this is how we achieved a double story and single story variation that allows for a generous living in sunlight as we use the post and beam system to expand and contract. You can see in the diagram, the bathroom is a prefabricated module and the main structure of the unit can be disassembled into panels and posts. For sustainability, the apartment also incorporates passive house principles, which includes double glazing, high-performing windows, great ventilation for indoor air quality, thermal insulation, and airtight construction. This is to ensure that each unit would be economical to operate and require minimal energy to keep them at a comfortable temperature. All of the units face north, while the bedrooms are located towards the south for effective cross-ventilation and enhancing the living conditions. There are also shared communal spaces such as laundry, rooftop deck, and garden that minimize the overall cost and create opportunities for engagement. Along with these elements, we are also including a rainwater storage system and permeable pavings to reduce stormwater runoff. Open walkways that connect the two buildings create moments within the community as well as the street below that positions this project as a homely place in the neighborhood. And due to its proximity to the tram stop and shops within the area, we not only incorporated communal garden and retail space, there are seats and bike racks available for those waiting for the tram as well. These are our main materials that we used in the panels, so cross-laminated timber and fiber cement sheet for our cladding, and then ceramic tiles in the bathroom and bamboo sheets for flooring because of its recyclable properties and low carbon emission. Within the kit itself, we opted to use CLT as our main structural materials and walls because from our research, CLTs are more sustainable, easily cut to size, and also connected via bolts instead of glue. And in response to the agility part of the brief, this means that in the long term, we have the flexibility to reframe this into a different configuration, but also its thermal and sound insulation property that makes it desirable. CLT panels are lightweight, which reduces the overall weight of the building and the foundation requirements. They also have a high strength to weight ratio, which means that they can support larger loads than other types of wood products. Their qualities also made it more lightweight while being structurally sound for a medium density project like this. And in terms of our services, we have designed the units in a way that optimizes space and reduce any unnecessary components that would make it less efficient. So the services connect vertically to the unit above or below with the same riser and also connected to the kitchen pipe and sinks in one central location for efficiency. This also allows us to use prefab services for this apartment as they are the same size and within the same location of the same apartment. So when it comes to assembly and manufacturing, the advantages of prefabrication shines because of its components being made before transporting to site. And in our project, each panel is 6 meters by 3 meters, specifically designed to fit on the truck of the bed to minimize transport costs and emissions associated with this. This is estimated to take somewhere between 2 to 2.5 months in order to fully complete the structure and install the services. And since our project utilizes standardized material and sizes to achieve economies of scale, we managed to save the overhead costs and minimize any risks associated with construction, especially labor costs and time that were major expenses. So a completed unit comes to an estimated cost of about $15,000 to $16,000 with all the plumbing and services installed. And in total, the project is estimated to cost somewhere from $2.5 million to $2.7 million, which includes permit application and transportation. Comparing this to traditional building method, that would be a minimum of $3 million. These are our architecture drawings, which shows the communal garden on the ground floor and then the laundry on the first floor, and then the communal garden and the rooftop on the second floor, showing interaction at every level. And these are our renders showing the connections between the two buildings through the walkways. Thank you.